problems or errors. So right now, we're gonna start with the installation of the Go programming language and the Go tools. And so far, currently we are on the version 1.4.2, and the Go team has been trying.
We cannot hear you.
Yeah, Rabia, you're that. I think your microphone's set right now.
Yes, you're mute for some reason. Can you?
Yeah, hold on. Let me try.
Actually,
there you go.
No, it actually muted me by itself. It's weird.
Oh, okay. All right, it's okay. Now we can hear now.
Where did you guys miss?
Say it after you started talking about how to install it.
Yep, we lost it there.
Yeah, that's easy. I didn't say a lot. I actually was talking about like the current version of the Go programming language is 1.42.
Okay.
And the Go team has been trying as much as possible to support most of the platforms and the operating systems like Mac, Windows, for the Linux packages for Ubuntu, Red Hat, CentOS. So if you go to this link right here, which is the GoLang org /install, you can see that most of the packages are supported. And in my case, I'm going to be installing the Mac OS X packages.
You're no longer sharing the screen. We see you now.
Ah, it's weird. Okay, here's the screen. Share. You can see her now?
Yes.
Cool. So since I already have the Go tools, but actually it's as easy as just choosing which package that you want to install for which distribution or which operating system you're working on. So in my case, it will be the OS X 10.8 64-bit, which is will be an installation of about 59 megabytes. So it's only a wizard. It's going to be like next, and it will install everything. So the next step for us, after you install the Go tools, we're going to go to the terminal. You guys can see it?
Yes, we can.
Okay. So we have to check for two things actually at the beginning. First of all, the version of Go that we have. Currently, I have the Go 1.33. And the second thing is the environment variables for Go. So there's two of them that are really important for you to start building on the Go tools to build your own application. Which is first is the Go root. The Go root is automatically assigned once you install Go, and it will actually direct to the Go tools, the built-in tools for Go. The Go path actually is one that you have to actually set yourself. And one extra flag that is interesting mainly for C programmers is the CGO underscore enabled. This one actually gives the ability for you to start building Go packages that can read C code. So it's more of like a freebie for the C programmers to start using Go. So right now it's set up on my side, but I'm gonna go through the step anyway. I'm gonna do export the Go path. Those users the code. So once I set my Go path, I'm just gonna check it just to see that it's there. It is there. So right now we're actually ready to test if Go detected our path and that it's running on it. So right now we're just gonna do. How about we do the Hello World example really quick right here. So I'm gonna open a file. So the first thing in a GoLang script or a package is to define what kind of package you are running. So the package main is actually reserved for the Go tools or the Go programming language, and that tells Go that this script is going to be built as a binary. I don't need it as a package to be reusable for other applications. I actually need it as to be generated as a binary because I want it to be executable. So after that, we can import the packages that we need. In our case, we only need to print. So we're going to use the package font. Font actually is the package responsible for printing and formatting. So the third thing is the main function, which is also reserved. And it tells Go that I need to execute this. This is the main function that, since it's called main, but it's the main function that Go runs, like the code inside of it. So we're just going to do print with a new line and do hello world. A quick way of testing it is to use the go run command. The go run command actually compiles and executes, like runs the script. So we're just going to say go run hello go, and it will output hello world. So the thing is, right now, using the go run command actually compiles, the Go tools compile, and the Go tools run the script, but it would not leave the executable for you. So if you want to create that executable, you have to use go build and give the Go script again. In this case, if we take a look at our directory, we're going to find two files, the hello.go that we did, and there is the executable right there. And you actually can notice the difference in size. Like the script that we already created is about 87 bytes, and now the executable is about 1.7 megs, which is the explanation for this is actually it compiled our script and the package that we used and all the Go tools that is needed to run a whole Go application. So that's why it is a little bit big.
I have a question.
Yeah, sure, man.
In the first run that you did, so if you do go run, it will compiles on memory or it use the temp file, like the temp folder to do the whole compilation thing.
No, it actually uses a temp file. It's not in memory.
Oh,
but,
okay.
Yeah. What I can't confirm if it removes it. Definitely, it removes it by itself. So after running, so it doesn't generate that executable. It just like removes it after execution.
Oh, I got it. Okay. Yeah.
Well, I can confirm that to you.
All right.
So yeah. Right now, if we go back to the slides, where's my slides? So after the installation, we went through the Go path. Again, just to emphasize on that because it's very important if you're starting to build with Go. Go path is the location of your project, and it's the location of any package that you install. So whatever third-party package that you want to use in your application, it has to be inside the Go path. The workspace.
I have a question about that. Sorry.
Yeah, sure, man.
Yeah. With the Go path, you told me that I need every time that I need a project. So if I have multiple projects, what you would recommend to have like a root project folder, and every single project that I have is inside that, or you recommend something like RBM or npm that they have like a .nbrlc file that every time that you cd into, it changes the Go path itself.
Well, actually, this option is left to you because right now there is more than one way of doing it. As you said, there is a way of where you can switch the Go path to each project you want to work in. That's one of the solutions. If you want like to use third-party packages that you don't want to use in a different one, that means you're going to switch the Go path from one directory to another. But if you want to have a centralized, if let's say a way to manage the packages and to have it centralized, you can use one Go path and just do separate packages, each one in its own directory, and that will be a solution. So it's actually left to you. There is no one way to do it.
Oh, but the Go path is related with your Go compilation. For example, if you're going to compile and the Go path is set up to a different folder that is not your file.go, that has any problem there, or it's fine?
It wouldn't detect your Go files.
Oh, I got it.
It has to be a specific place for it.
Got it. Okay.
So after we set up the Go path, and as we've seen, like in the root of that Go path, you can actually start running scripts. It's not you don't need to have more structure or more directories to make Go work. It just works by itself for scripts. But let's say if you want to create your own package, that's different. So this is where you have to set up your own workspace. So the workspace is actually consisting of 3 directories. One of them, the source, is actually the directory that you have to manage yourself. The PKG and the BIN directory, both of them are created by Go itself. The source directory contains the source files organized as packages, and you will write your Go applications inside this directory. The package, this directory contains Go package objects, which generated by the Go tools. The BIN, which this directory contains executable programs, which is a generated executable after you compile. So we already did the hello world example just to emphasize on the couple of points that we said while we were writing the example. This is a reserved package that Go looks for first in your application, the package main. So if you're building an executable. And the second import, where we have the func library, is actually a built-in library. It's under Go root, and the packages from the community, there has to be, they should be under the Go path, as we said. And this is, of course, the func main is the root function and the master of all functions, and if it's done executing or an error happened in your program, it will exit. And if it exits, your whole application exits. So right now, let's introduce like another library, and also the idea of importing and casting in Go. So if we take this example and run it again here, if we can say import Go. Oops, that's gonna be ugly. So let me open it in a.
You can put set paste.
Yeah, well, I would go Sublime right now, just for the time being. Just give me 1 second. So yeah. So if we open our Go path right here. So again, mainly just to, while I set up this, they're actually promising for the 1.5 version of Go to cut the compilation time to half, which is very interesting, since right now they've been improving a lot on the built-in libraries that they have. So there has been a lot of improvements lately. So we're now on it. Okay, so let me create a new file and paste it right here. Save it to import.go. So right now we're trying to. It's a simple example. We're just trying to get.
Sorry, can you increase a little bit the font?
Oh yeah, I'm sorry, man.
Yeah, remember, I'm blind.
I understand.
Thanks, man.
Oh. So we imported a new built-in library which is called math, just to loop 100 times and print the power of 2 of the variable that we already defined and we're looping on it. And actually, this is where the POW, which is the method for math, it actually does not allow you to pass an integer for it. You actually have to cast it to float. And here we are casting it to float 64 before telling it to multiply it by itself and print it. And at the same time, as you can see, guys, there is two things that are a little bit interesting, which is first, if you initialize this variable, you don't need actually to add it right here. You can just skip that step and continue with the condition or the loop. And actually, right here, you can see that we don't have a parentheses for it. So we're just checking if it's even. If it's even, we're just printing even. So if we save this and we run it, it's going to print all this. And we can notice the time, actually. If I go run import with time, it takes about 0.3 of a second. But at the same time, if we build it, just to give you an example of why compilation matters, and the import, we have the import executable right now, so I can run it with import right here, and it actually took 0.005 of a second. So there is a big difference. It's actually just a small example of how powerful it is once you compile, and the difference between a little bit of difference between it and others, let's say scripting languages, or running your code without compiling it. So next example, I actually created a small class just to give an idea of whoever is coming from different backgrounds. This is a PHP class. It's an Go programming language doesn't have classes, actually. So, but in our example right here, it's just a class called rectangle. It has two variables, two methods. One is a constructor that just assigns the width and height, and then just a method called area that just outputs the result. So how do we translate this in Go? In Go, there is something called constructs. Those constructs actually it just containers for data that through them you can actually, for people who are like more likely to see that object-oriented languages are more favored by them. It's close enough, but it's not the same. There is no inheritance. So, but this is the example, exactly the example, like the example above, but in Go. So first of all, we define a struct. This struct is called rectangle. It has a width and a height, and you have definitely to tell it what type it is, like for the two variables inside the struct. And then the way you define a function and call it a method for that struct is actually that you prefix that function with the rectangle type from the struct. So actually, if we take this example right here, so let's create a new file and call it struct. So, okay, I'm just gonna minimize it a little bit. Okay, so right now, if we remove this from here, right now this function has nothing to do with our struct. So the only difference is that you have to add to prefix it with the struct, and Go will understand that this method belongs to this struct right here. So in our main function, we're actually giving an example of how to start a new struct, like creating a new class. So when you create a new struct and you just define those width and height with different values, and with the and so you take the variable of the struct, which is new rectangle dot width equals width of 10, and the new rectangle height equals 50. So, and we are printing right here the struct dot the method, and where it go recognize it by itself. So if we can run the construct, it's going to give us 500, which is the area for the rectangle. Again, I'm just going to build it real fast just to give the same example and just compare how much time does it take. So 218 in this case, and if we run it from here, it will take a 0.06. Oh,
I have a question.
yeah, go ahead.
Well,
Please.
I don't know if you're going to touch that point afterwards, but since you don't have inheritance on Go, what would be the workaround in case that you need to like extend it? Or I know, well, it's not classes, but how you will extend a structure in this case if you need to.
To extend, there is no way to extend, like extend a specific functionality, you mean?
Yeah, I mean, I'm just trying to come up with the example, like if you have a class called shape and then you have rectangles and circles. In case that you have to represent that in Go, will you do it like different variables each one, so independent? You don't have to um, like think about inheritance in this case, or what will you do is just, you know what, everything is a different structure, so use it as it is and that's it.
Well, actually, there is a way to work like around it, which is like embedding whatever struct that you want to extend in the new struct that you are creating. I don't know if you understand what I'm saying, but
Yeah, you were saying creating a main master structure, and every single structure that I need will be inside that one, right?
yeah, the master will be embedded into the new one that you are creating. This is one of the ways to do it.
Okay, okay.
So structs, just to summarize it, are typed collections of fields. They are useful for grouping data together to form records. And now the good stuff. Now this is one of the things that Go has that as a built-in feature, which is the Go routines. So a Go routines has a simple model. It is a function executing concurrently with other Go routines in the same address space. So the idea of the address space is just a generic term, you can say, but you can think about it that since processes, when they switch in an operating system, the operating system has to keep record of all these changes and all the contents and registers. So, and the threads at the same time will need to share memory. I don't know if I'm confusing you guys more than explaining it, but so the idea is that the Go routines are something that abstract that works over the threads. So it's not a thread by itself. So if we go to the next slide, the Go routines are a lightweight abstraction over threads. And the benefit of this is that a Go programmer does not deal with threads, and similarly, the OS is not aware of the existence of Go routines. So when the Go teams created the language, they were actually thinking about a way to work with concurrency, but actually not to get to a point where you have to manage threads on the operating system level. And at the same time, the OS is not aware of anything that is called Go routines. So he actually looks at threads and nothing more. There is cases sometimes, I'm sorry, there is cases sometimes where a Go routine can block a thread. but that wouldn't block your application. 1 second. Sorry. So there is sometimes a Go routine can block your application, your thread, but actually the Go programming language is going to try to. I'm sorry, I need to close this. 1 second. All right, I guess it's closed. So right now there is an example, a simple example of the Go routines and how it's implemented easily inside the Go language. So we have the usual. I guess you guys are already getting used to the idea of the package main importing and the main function that we're doing most of the logic inside of it. So we're defining here a function called f that takes a string, and we are looping for 3 times just to output the variable that we have. So right now, 1 second, excuse me, I'm sorry. Sorry for interruption or the continuous interruption. I don't know how to close this thing.
No worries, man. No worries.
Don't worry. There's no way to close that.
Yeah.
There is no way?
No. So.
Okay. 1
Yeah,
second.
that's the hard part of the Mac life, right? You know, you just can close things.
No, Juan. I think this is a good time to discuss about Mac, since we are better. All right.
1 second. So I can get rid of this.
Would it work if you turn the phone off?
Maybe.
I don't think so. It's been ringing on my laptop. So,
Stop calling me. I'm live.
It's alright.
yeah, I just got it. So back to the action. So right now, we created a function. It only loops like 3 times just to output this I variable. So there's an example of how to run it synchronously. We run it inside the function main, and we say f, and we just give it a string just to show that this is the one that's running synchronously right now. So running things concurrently, you just need to add the Go keyword before your function, and it will actually run in a Go routine by itself. So it will be isolated inside a thread, and it will run by itself concurrently, and it wouldn't care if something is of any sequential code that is running right now. Another way of doing it, maybe some people like to do anonymous functions, create anonymous functions, and this is also a capability in GoLang. You can actually add the keyword for Go and start defining this function. Tell it that I need to receive a string and print this string. And actually, at the end, you assign that variable or that string that you want to, the value that you want to pass to that function. So at the end of the function main, we just don't want it to exit before we tell it to exit. So that is only a way of asking for input from the command line. So whenever you click any key, it's going to just print done and say that it's done already. So if we take this example right now and run it, I'm just going to use Sublime. Not going to fall for the same mistake. All right. If we do a new file, Go routine, we save this file, and we run it from the terminal. So if let's build it first, just to have the executable ready, and then we're going to run it. with the time command. Sorry. Will actually run the synchronous function, and also the Go routine is going to run. But because it's like a small example, it's not going to show like if the Go routine is actually working concurrently and by itself. But right now, if we take a look at how much time it took, let's run it again, just because it's counting how much time to like click a key, so it's not going to work. But I got. You guys have any question about it, about the Go routines? I can explain it a little bit more. If anybody wants me to explain it more.
Well, actually, I think it's pretty straightforward how they define this Go routine, because you just have to prefix with
Yeah, I
this.
feel
Yeah.
I feel like they made it really easy in a way. So especially that a lot of people, it's not my own experience to be honest. I read about it that a lot of people were having uh, big amounts of issues with concurrency and dealing with concurrency in different languages that supports it in a way or another. So coming from that experience, I guess they tried as much as possible to make it easy for you to make use of concurrency.
My question would be, and if you know or you read about which of what the sample that you show is the best approach to use, like just go with executing the function and passing it, or prefixing with or using closures in this case, anonymous function.
My personal preference, I like for it to be separate functions out of my main function. I guess it's more like making your code neat. It's not about like performance or if it differs in performance or.
So you're saying the first or the second one?
The first one.
Okay, got it.
What about you?
I don't know. I just want to know because I actually don't know. I mean, I've been playing with Go like really few times. I haven't go that deep, so I just want to know what would you suggest in this case.
No, it was just a question because in most languages, like in languages that support anonymous functions, or like it's a preference for each programmer. Some people prefer like anonymous function.
I would say it depends. Yes, option one is really clear because you have a separate function. You have that much code in one place that you may, if you want to like go back and see, okay, what I'm doing here because it's another function, you actually don't know. There's no any indicator. But I don't know if do you have any cost in performance having a whole function running in anonymous way. So if it's something like I don't know, it's consuming more memory or something like that. So that's what I would say, like, I don't know which one.
Well, I never researched it, but I can tell you what I think it is. So function main right now itself is a Go routine. So it's actually a part of a thread. So if you're adding more to it, like putting an anonymous function that's going to run as a Go routine and whatever it's going to return to print it, I'm sure it's going to be like more memory for that Go routine, which is the main function. So I think that's like right now I just thought about it. It's not something that I know of, to be honest.
Okay. That's pretty cool to me. I mean, I like the first one too. It's clear.
Yeah.
And easy to read.
So right now, Go routines, since they have their own memory, but they don't share it. Go routines can't see each other. Every one of them is running concurrently by itself. It's going somewhere to give output from an input it took, but at the same time they can't communicate in any way. But actually, the Go programming language offers something called channels. Channels are the pipes that connect concurrent Go routines. You can send values into channels from one Go routine and receive those values into another Go routine. And actually, the Go team is always emphasizing that we do not communicate by sharing memory. Instead, we share memory by communicating. So we're actually, whatever data you want to give from one Go routine to another, you actually should be passing this memory through those channels, not actually share all your memory, and the communication will have a lot of problems and a lot of issues. So an example of channels right here, as we said, we use channels to synchronize execution across Go routines. So right now we have only a function that is called a worker. It's passed a channel of type Boolean, and it just sleeps for 1 second, and then it passes the value to the channel. So the way channels work is actually only a left arrow that either goes into the channel or goes out of the channel. This is the only way. There is no right arrow. If you want to write something to a channel, it has to be a left arrow to the right of the channel. And if you want to get something out of it, you're going to put the left arrow to the left of it. So in this example right here, it sleeps for 1 second, it prints working, sleeps for 1 second, prints done, and it then sends the value true to the channel that is called done, that is passed in the parameters of the function. So in our main function, we can see that we created a new channel of type bool, and it has one value to pass. It's only one value that is passed between Go routines. So once we run this concurrently, it actually will wait till the true value goes into the channel, and once it gets there, it will exit that program. So if we take this example right here, and let's execute it. Let's go run the channel. It's actually working, and it gives done. It gives done once the channel has sent that value already, as we've seen in the example here. So it sleeps for 1 second. It passes this value to the done channel, and once it's done, it prints and exits this. It exits the program. So the thing is right here that it will block, because as we said, the main function is actually a Go routine by itself. So you're actually passing from the Go routine for the worker function to the main function, and it's actually waiting, and it will block till it finds that value coming from the channel. So talking about the values right here, the one, we actually can buffer a channel. There's a specific buffer that you can specify when you define a channel. Let's say we want to buffer it to 3. So actually we want to pass 3 values from here to here. In this case, we actually have to receive those 3 values for the program to understand that it should stop blocking and exit. So if we run this again, it's actually working. It will wait for a second till all the values gets from the channel to the other Go routine, which is the main function, and then it will exit. Let's just build that. You guys just to understand. 1 second. Channel. Okay. So we have channel. There is not a lot of difference, I guess, in the execution time. Okay, so a small review of what tools has been built with Go currently. So right now there is a lot of them, but actually I'm just gonna show a couple of them. Docker is one of the platforms that are used to develop, ship, and deploy to distributed systems. It has been there for some time, and it's been known a lot, and a lot of companies has been using it lately. RNMQ is actually it's built on Go, and it's a cloud solution, a queue cloud solution. Bitly actually had their own queue actually, and um, they published it on GitHub. It's called NSQ. Um, the one with the gopher, it's called Gogs. Gogs is a self-hosted Git service. It's like GitHub, but you actually can host it yourself. So those are like a couple of examples of Go programs that has been built right now. But actually, also big companies has been adapting Go in their services, building their services with Go, and noticing how the performance of it is actually helping their business needs and everything. So Twitter actually uses Go lately, and they have one of their articles on their blog saying that handling 5 billion sessions a day in real time. And what they actually did is they built all their API with Go, and they've been reading most uh, of it from Kafka. There is actually more details inside the article. Cloudflare, the same thing. They've been using Go for the last year, I believe. DigitalOcean is a big shop that is using Go. This Shopify, I actually read it today. Uh, I've seen the tweet that they're actually adding Go to their stack, and the list goes on. Yeah, there's actually a link right here that shows um, most of the companies that are using Go in their production environments. So you can take a look and see if anything interests you.
Yeah,
And
that's very cool.
thank you very much. And if you have any questions,
Yeah, I have a question.
please do.
So, well, I have two different questions. So the first one is, what would be the best practices that you have found so far to work best with Go?
So in a small application that I've been building lately, I had a couple of things. One of them is package management that we were talking about, me and Angel. This is one of the things because as I researched a little bit, I've seen examples like DigitalOcean, where the packages, especially the community packages that they're using, they were facing a problem that every time um, any updates comes to one of the packages, they have to update it on their own platform. So their solution was to actually fork those packages and support them themselves, and have them centralized for all the services that use them. So that was one of the challenges that I had, to be honest. The second thing that I noticed, or like when I was working with it, um, is that as much as there is a lot of documentation and it's very interesting that they are always like updating it, at the same time there is not a lot of examples. Like some people like learn by example. Some people like to read
Yeah.
long pages of text. I'm not the first. I'm not the second type. So this is actually
How about Stack Overflow? Is really a lot of information there already, or there's still?
it's growing. It's really growing. But I'm not gonna say like it's huge as other languages.
Okay. Um, one, you have more questions, or I can ask one more question?
Yeah,
Go ahead.
I have another question about the syntax.
Yeah.
How do you because I was just trying to write as you were writing code along, and it kind of bit me in my behind that there is a difference meaning there's a different meaning of double quotes from single quotes in Go.
Yeah, that's true. Well, the thing is, I had a couple of issues with it, like with because coming from a let's say a PHP background, I had a couple of issues. One of them is the semicolons. One of them, the whole idea of not just looking at it just per line and on tab based. It's a little bit hard, especially coming like for me coming from a scripting language like PHP. So
And JavaScript.
Yeah, talking about that, the assign operator it really beat me. The colon equal.
yeah, it's yeah. Let me give you an example. That'll be easier. So right now, if you actually want to define a variable, let me share my screen. Actually, am I sharing my screen? No.
No, you're not.
Okay.
Yeah, well, when I saw the assignment operator, I thought it was like one-way data binding, like in.
Yes, yes.
I was
That's
like,
what
what is that?
that's what mean to me.
You actually either you say like I want to var x of integer and then equals to 10. This is one way of doing it. But sometimes if you have already a value like this var x that is already defined, and you want to define another variable that has the same type and value, you just actually do y with a calling and equals x, and that's it. This way, Go understands that this is the same type and the same value. So it will do it for you. Or you can just add like 5, and it will also understand that at the same time. It's a shortcut,
Okay.
which is good, but at the same time, you can say in the best practices is for you to actually declare before and then assign the value if you have a value.
Oh, okay.
Like at the beginning of the application, of course. But it's not a bad practice again. So
Maybe just preference.
yeah.
Yeah, I do have another question. Is about channels because that's maybe the topic that everyone try to
Try to
explain.
understand that.
Yeah, because it's hard. This is the only language that actually have channels or the concept of channels.
Yeah.
Well, from what I saw that you explain is like correct me if I'm wrong. One, they use the same kind of concept how zero and Q communicate between process. So
Yes, you can say that there is. It's more of only one sender and one subscriber.
hmm
But if you have one that is buffered, you actually can pass to multiple Go routines. So,
okay, so explain that. That's
so
what
the,
it confuses
the
me.
idea of a buffered channel, the
Mhm.
idea of a buffered channel is just telling it that it's a pipe that can take um, what do you say, like 3 dogs can pass through that pipe.
Okay.
So and the first one or the default behavior is for only one dog to pass there and to go to the other side. So you actually can. So the idea of the buffered is that whatever value gets first, if the 3 dogs comes in, all of them has to come out, but that doesn't mean it has to be the same order. And actually,
Mm.
one thing I have to note that even if you close a channel, it doesn't mean that you can't get info from it. It can just feed you info till it's done.
So it's not. I mean, if I understand what you said, so the channel you don't have any assurance that the whatever you put in is going to come out, or
No, no, no.
uh,
I have assurance. They have to come
you
out.
have assurance. Okay, okay, I got it. All right.
Maybe
Yeah.
just not in the same order as they came in.
Yeah.
Okay.
And I have
So
to double check about that, but yes, if you get 1, 2, 3, that doesn't mean you're gonna get 1, 2, 3 in the same order.
okay. So that's pretty cool, man. That's pretty cool. It's like having, of course, I had to compare with something that I know. It's like having zero and Q built in the language.
Yes.
Now, I have another question. What are the things that you should not use Go for? Like, for example, if you're doing Node in JavaScript, you're not going to use Node for really heavy processing, CPU intensive tasks or synchronous tasks. You're going to go like asynchronous and high I/O tasks. So what do you think, or what have you found Go not to be good for?
Well, mainly Go right now, especially with companies that are using it, they are using it for back-end services. Let's say, which is actually mostly the opposite of what Node.js can't do or shouldn't be used for. You actually can use Go for it. Now, if you want to actually use it for to build a web application, you can do that, and it's already the library already have a built-in HTML templating, so you can do that if you want. But it's not meant for that. It shouldn't be, I guess, like from my own opinion.
Yeah, I think we discussed about this once. Is for example, we can bring two examples in this case. Like RNQ, they actually replaced the API that they had on Ruby with Go. But it makes sense because they are a queue system, so they need really good speed. So Ruby, it doesn't mean that they didn't provide it. It's just that they already passed the limits of what Ruby can accomplish. So instead of throwing more money into the solution, they just rewrite. And they actually have the in the article that I wrote, they reduced the service in a big amount, like almost 50% or more service. So that makes sense. In case of Shopify, I don't think they're going to change the API because the API is not actually the main thing that they may has to replace. So they will go more to the backend services like processing images to the city and processing a API keys, whatever they do in the backend. So that makes sense, at least in my opinion. No?
Yeah, you can categorize it under like the heavy lifting.
Yep.
That's what Go or mainly I'm not gonna generalize, but I would say like it's mainly any compiled languages can do like the heavy lifting of any application.
That's true.
But the advantage is that you get like free compilation time and you got concurrency, so it's just package with everything in it.
That's true. That's true. Any other questions? Well, I don't see any other questions online. So
I have one question.
Oh, go ahead.
You said it's good for the server backend because it has concurrency and kind of like multi-threaded kind of sub-thread, I guess. But what is the front end people use usually with Go? To front end,
All right.
like if they're you said other companies are using it. What programming language they people use for the front end? Like they use PHP. Are you using PHP for the front end, and then back end you're using Go? If you make an application that's has a user interface.
Yeah, the idea is once your backend is ready and you have a ready API built, you actually it's the matter of you just consuming that API. So if you consume it with PHP, Node.js, JavaScript, it's
as good with anything, right? Okay.
Exactly.
Yeah, that's cool. That's exactly the sample of Shopify. You can consume with any other language. It's fine.
Yeah, which is actually like I would say it's very wise because you already have a Ruby application that you can just replace its API with Go and leave it to do any other processing that you need after you get data from that API. So it took some weight from the Ruby application, which is a very smart move, to be honest.
Yeah. Well, yeah, no, yeah. Then at least on Zero and Q, they really did a really smart move. picking from the Ruby guys. So, any other question?
No, I'm good.
Very good. I think we're just about the time. So I
Thank
think
you.
we're good.
You're
So
welcome.
I was thank you all for joining us, and I hope you learned something new, and this is helpful.
Well,
And thanks, Rabia, you did a great job. Thank you so much, and
Yeah.
and see you and see you in the next gym workout fitness.
I'll do.
All
Subscribe.
Next time.
All right, guys. See you
right.
later.
Bye bye. Take it easy.
Bye bye.
Have a good night.
You too. Thanks.